So in the previous lecture, it got like paused at this point, right? Like in the permutation thing. So what I was explaining is what we have here: 5 men and 4 women sit in a row such that. So they are sitting in a row. So women can be sit in any four even rows, okay? But we are not bothered about how many places are there in previous that sum and all. How many places were there according to that we're doing. But here, how many objects are there according to that we'll do. So objects are as what 5 men and 4 women. So how can they be arranged as how many such arrangements are possible there are? So simply what you have to take 5 factorial into 4 factorial you have to take 5 factorial 1 into 2 into 3 into 4 into 5, right? Like that again into again 1 into 2 into 3 into 4, that is 120 into 24, so 2880. Okay. Similarly, second question, let us move on. How many different strings, okay, sequence of length 4, okay, can be formed using the letters of the word FLOWER? Okay, solution. Flowers has 6 letters. Okay, now what we have 6 letters we have. Among 6 letters, length here what is here the length is 1, 2, 3, 6. The length is 6 here, but they are asking the length should be 4. So, flowers has a letter of all of which are distinct. The required number of strings is the number of permutations of 6 letters can chosen 4 at a time. Okay, so now you have to apply that formula P of n comma r, where n is what to say 6 and r is 4, which is equals to 6 factorial divided by 6 minus 4 factorial. That is nothing but 2 factorial. So 2 factorial, but only 2, because 1 into 2, then 6 are 1 into 2 into 3 into 4 into 5 into 6. So 2 and 6, 2 will get cancelled. So you will have only 3 into 4 into 5 into 6. That is your answer. That is 360. Then find the number of distinguishable permutations of the letters in the following words. So we have to find distinguishable permutations of the letters. So basic in the following. So first one, the word basics has 5 letters. All letters are being distinct. N is used. So the number of permutations of basic is 5 factorial. That is 120 factorial. If you see in calculus, C is repeating 2 times. Okay. Now see here, amount in calculus, C is repeated 2 times, L is repeated 2 times, and U is also repeated 2 times. Okay, U here, U 2 times, L 2 times, C 2 times, and then remaining only A and S is 1 time. So the required permutations total, how many are there? First 1, 2, 3, 4, 5, 6, 7, 8. N total N is 8 divided by 9. How many number of times the letters are repeated that we have to write? Number of times. See here, you just have to multiply 2 factorial, 2 factorial, 2 factorial into 1 factorial into 1 factorial. Okay. Then what will be the answer? That is nothing but 8 factorial divided by 2 into 2 into 2, 2 to the 4, 4 to the 8. 8 factorial divided by 8 will be your answer. You understood that how we took this. It's nothing but what they're saying. Distinct letters should not, it should be distinct, okay? Whatever the permutation we are getting, it should be distinct. Means the numbers should not repeat here. So for numbers not to repeat, first you are seeing how many numbers are being repeated. So this is repeated 2 times, so we are taking 2 factorial. This is repeated 2 times, so we are taking 2 factorial. Which is repeated only 1 time, we will take only 1 factorial. And then just divide it. Same way, the word mathematics has 11 letters in which, okay, n is 11, in which, see here, M is 2 times, A is 2 times, D is 2 times, then remaining just write H, E, I, C, S. Now what you will do? Total numbers 11 divided by this factorial, this factorial, this factorial into this factorial, like that, so on. See, that's it. Whatever the answer, that's your answer. Same way in structure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 times letters are there here. In that, how many times repeated? See, 2, 2, 2, R 2 times, U 2 times, then C 1 time and E 1 time. So what will be the answer? 10 factorial by this 2 factorial into 2 factorial into 2 factorial into here also 2 factorial and then 1 factorial. Answer. Then same way in engineering. Engineering has 11 letters where E has repeated 3 times, N has repeated 3 times, G has repeated 2 times, I has repeated 2 times, and R has repeated 1 time. So total number is 11. 11 factorial divided by 3 factorial into 3 factorial into 2 factorial into 2 factorial into 1 factorial. Simple, right? How many times you're getting? Just the denominator itself, same way it's been written and over. Now we have an interesting question over here. They are saying find the number of permutations of the letter of the word Masasauga in how many of these all four A's are together, how many of them begin with S, they are saying. So given word has 10 letters, of which 4 are A. Okay, 1 time A, 2 time A, third 3 time A, 4 time A. 3 times S is there. S is how many times? 4 times A is there. 3 times S is there. 1 time M, 1 time E, 1 time G. So number total permutations will be this many times. Okay, of letter. So how many ways all the four A's are together? Okay, how many of them begin with S? Okay, first this is done. We found the total permutation. That is what to say. They have tricked here, but still four A's are also there, which means 4 times A will be there. We have just normally how we found it for these things we will find here. Then how many of them begin with S? So how many of them will begin with S? So it has to begin with S. So here S 3 times are there. If in a permutation all A's are to be together, we treat all A's as one. Okay, so first here we have found it only a permutation, total permutation. Now actual question what I have asked. First, we have found the permutation. This question. Now, how many ways all of these, all fours are together? All fours are together means A, 4 times A are there, right? This all I will consider as one now. They are together. So, these four A's are one term. So, here what is the same difference? Nothing will happen. This 4 is there, right? That 4 will become only 1 because 4 times was there. I am consider this as only one time, that is A. So, this 4 will become A. Then, whatever the answer getting, just write it off. And then for permutation beginning with S, these occurs there occur 9 empty positions to fill, okay, where 2 are S, 4 are A, 1 each, and M U G. So what I'm doing here, I'm just taking S as I'll remove S and put it in first place. So if I use I'm using S in one place, so remaining whatever are there, remaining positions I have 2 times what to say S, 4 times A, and remaining 1 time M, 1 time U, 1 time G, like that. So total, and see in the denominator here it was 10, right? But here I have 7 factorial. I forgot to mention that. Why it becomes 7 factorial? Because totally I had 10 letters, but I am considering 4A as 1. So here 10 times, and that last after 7, 8, 9, 10. This all 4 were 10. Suppose these all 4 locations were 10. Now I am considering this 4 as 1. Okay, so he previous was 6. So 6, then second will be this 4 will become 1, so that only 7 factorial. Here, same way, it was 10, but I am not considering one S because it begins with S, right? So this will be fixed position, first letter. Where is that letter? Okay, first letter will be fixed as S. So both in numerator and denominator, 1 will reduce. In numerator, instead of 10, 1 will reduce and become 9. And in denominator, we used to write 3 for S, right? That 3 will become 2. Remaining everything is same. See here, remaining everything is same. Whatever you are getting, just write it as your answer, done. Then second, same way, instead of Masanga, they have given this number. Same way they have asked, I won't be solving this. Anyhow, it's very simple and small, you can see here. Okay, I'm just pausing it so that you can see here. Done, done, done. Okay, in how many ways here means are there for all letters in the word sociological? How many ways I can arrange this all? First, whatever I'm having, right? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 factorial divided by, then you have to find how many times each letter is repeated. Those many times you'll just write in the after like that. See here, like this. Then they have also asked in how many ways of this arrangement A and G are adjacent. Means A and G will be beside each other. Okay, and then all the vowels are adjacent. So see, for A, A1 has 12 letters, of which 3 are 0, 2 are 2 each are C. C is 2 times, I is 2 times, and I is what is it? And 1 each time. Okay, 1 time S, 1 time A, 1 time G. Okay, so they have asked if in arrangement A and G are to be adjacent, we treat A and G together as single letter. Simple. So here see here A and G will become 1. So now what will happen? Instead of 2 letters, I'll have only 1 letter, and in numerator, numerator won't change because anyhow this was 1 time, this was 1 time, this was 1 time. We are considering 1 factorial into 1 factorial into 1 factorial. This 2 will become 1. So instead of adding 3 times 1 factorial, I'll add only 2 times 1 factorial. See, instead of 3 times, I'm writing 1 time. Then same way, They have said also then what they have said, all the vowels are adjacent. So A, E, I, O, U. So in this I'll just remove A, E, I, O. So A, E is not there, I is there, O is there, and U is not there. So A has come one time, U has come what to say 3 times, then 2 has come 2 times. So here see here now where I'm grouping A, O, I as one as single letter, say Y, such that there are two C, two L's, one S, one G, and only one time Y. Y means one time only A, which is whole letter Y. Now I have to find. So how many times? 1, 2, 3, 4, 5, 6, 7. Total letters will become 7. Just here, total here where 11 was there, 12 was there, 12 letters were total. In this, what I am doing, I am removing O. How many times O was there? 3 times. Right? I will remove 3. I will remove 2 times of I. I will remove 2 times of what is say A. How many times OLs are there? I will remove all them and just add one like that. That's it. It's very simple. If you see it, you should be able to understand. How many 6-digit numbers can one make using the digit 1, 3, 3, 7, 7, 8? So now what is saying? How many 6-digit numbers can be made? Can one make? Okay, using 1, 3, 3, 7, 7, 8. How many times? So here n is 6. Okay, the given digits are 1, 3, 3, 7, 7, 8, in which there are, see, instead of what to say alphabets, they have just given us numbers this time. So now what I'll see here, 1 has come one time, 3 has come 2 times, 7 has come 2 times, and 8 has come 1 time. So now what I will do, the number 6 digits numbers using the given digits is total numbers what, n factorial divided by. Now here simply how many times on 1, 3 is 2 times, so into 2 factorial into 2 factorial into 1. Same how letters were there, instead of letters only numbers are there. Consider these numbers as letters and just solve in the same way. How many positive integers n can be formed using the digit 3, 4, 4, 5, 5, 6, 7? So how many positive n integers? So if you want n to exceed 50,000, sorry 50 lakh. So now what they're saying, I have to use all these digits and I have to form a positive number, total number of positive numbers which will exceed this 50,000. Okay, now see here, I have how many digits? 7 digits are there, out of which the first letter should be okay either 5 or 6 or 7. Why? Because it has to exceed the 50 lakh, right? So I have to keep either my C 1, 2, 3, 4, 5, 6, 7. So for it to in order for it to exceed 50 lakh, so this should be either 5, either 6, or either 7. Then here any number remaining numbers I can put. Understood, right? Okay, so now what is saying? If x1 is equals to 5, then x2 is equals to 7 is an arrangement of the remaining 6 digits which contains 2 4s and 1 each are 3, 5, 6, 7. Now see here, I am taking this number. First I am keeping it as 5. If x1 is equals to 5, then remaining how many numbers are there? 1, 2, 3, 4, 5, 6. 6 factorial divided by 1 factorial. 4 has come 2 times, so 2 factorial. Then again 5 is only 1 time 1 factorial. Then 6 1 time 1 factorial, 7 factorial. Same. Now I will consider 6. Okay, I took 5. Now I will consider 6. So 6 remaining number is 6 factorial divided by 3 has come 1 time, so 1 factorial into 4 has come 2 times, so 2 factorial into again 5 has come 2 times, so again 2 factorial. See here, 2 times 2 factorial, then remaining 1. Now if I will consider 7, same numerator will be 6. Here also see, if I consider 7, it is the same case as considering 6. So 1 factorial into 2 factorial into 2 factorial. See, 2 factorial into 2 factorial into again 1 factorial. So you got 3 numbers. This first thing was 360, then you got 180, again you got 180. Okay, then now you have to just add all these numbers. That will give you total number of arrangements which is greater than 50 lakh. Okay, I have explained it very fast and also in very simple way. Now, in how many ways can 6 men and 6 women be seated in a row? First, they are saying if any person may sit next to each other. Okay. Second, if men and women must occupy alternate seats. First, we will see if any person may sit next to each other. no distinction can be made. So no repetition. So between men and women in their sitting. So total number of ways can be seated is 12 factorial. See 6 men, 6 women. So I'll just add it. 6 plus 6 total obviously will become 12. So 12 factorial. Okay, see that it is 6 plus 6 factorial. Now, if men and women are to occupy alternate seats, 6 men can occupy in 6 factorial ways in odd places, and 6 women can be seated in 6 factorial ways in even places. Number of ways in which men can occupy odd places and women can occupy even places is 6 factorial into 6 factorial. Here we had taken 6 plus 6 factorial total permutation, but here we are multiplying. In the beginning also it was there, right? Addition was there. Any one total, like any one seat, how many ways everyone can occupy, like that. So that way here, out of that they have given another example, same way. Okay, this men can sit in order 6 factorial ways, women can sit in even plus 6 factorial ways. Now I have to multiply this, I'll get this answer. Okay, then multiply the number of ways in which men can occupy even places and women can occupy odd places. That is again same way, 6 factorial to 6 factorial. Alternate, right? Alternate is first what I'll do. Suppose this is odd and this is even. First I'll make men sit here and then women sit here. I'll find the permutation. Then I'll make women sit in even place and men in odd place. Then I'll find the permutations. Same, same. Then what I'll do, I'll add this and this. Okay, I'll add this and this. Okay, that is total number of ways. Now, then question for non-negative integers n and r. If n plus 1 is greater than r, prove that p of n plus 1 comma r is equal to n plus 1 divided by n plus 1 minus r p of n comma into p of n comma r. Okay, this is one kind of what to say uh, share and type. We have p of n comma r is this is given. We know that. Okay, this thing, and p of n1 plus n1 n plus 1 comma r is equals to this. This is given. Therefore, p of n plus 1 comma r divided by p of n comma r is equal to, we are just multiplying this with this. Okay, sorry, dividing this and this. If you divide this and this, what will happen? Okay, n plus 1 factorial divided by n plus 1 minus r factorial into n minus r factorial into n factorial. How it is coming, you can see here. See here, if I write this, this can be written as n into 1 by this, and this can be written by n plus 1 factorial into 1 by this. Okay, so it is being divided. So n factorial divided by n minus r factorial. Again, this is there, right? So here n plus 1 is there, and here n plus 1 minus r is there. So if I bring this up, so this was in denominator, this will become go to numerator, right? Okay, same way, but here they have taken this first. So this is in the numerator and this is in the denominator. If you take this up, it will just ulta, it will become ulta. That's it, right? And you have to multiply now. N plus 1 factorial, n plus 1 minus r factorial into n minus r factorial into n factorial. Now, what they have done here? So here, what they have done? Here they have n plus 1 and here n factorials. This into this. See, they have just separated again. If you just multiply, you can write this two in a same line, this two in the same line, and then again they have just grouped here since it is in multiplication, right? See, this is multiplication, so they have taken this by this and this by this, which is equals to, now see here, n plus 1 into n. So n plus 1 into n, here n factorial into n minus r factorial, n plus 1 minus r. So what they have done? Here they have taken n minus r outside, here they have taken n plus 1 outside. So if they take this out in the inside the factorial, we can take this out. How? It is because I see this is n plus 1 factorial, right? So the next term, previous term will be here only n factorial. Okay, this factorial is nothing but this into the previous term, this term minus 1 factorial. Same way, n plus 1 minus r factorial can be written as, this is suppose what I am saying, n factorial is nothing but n into n minus 1 factorial, right? Now here, this is whole thing as n. This thing into this thing minus 1 factorial. This thing into n plus 1 into n plus 1 minus 1, that is nothing but only n factorial. Same way, n plus 1 minus r into same, what is this? This minus, I have to take minus 1. N plus 1 minus r minus 1, that is plus 1 minus 1 cancel, only n minus r is remaining. Now here what they did? So directly I will get, here you can see now, I have here n cancel, cancel. I have here n minus r factorial, n minus r factorial cancel. So remaining is n plus 1 divided by n plus 1 minus r factorial. Thus, this is equal to, this is very simple, right? What you have to give, say from the given question, this is there, and we know this formula. You just have to divide this from this, and you will get the answer. In 4 different mathematics books, 5 different co books, and 5 different GTC books are to be arranged in a staff shelf. Wow. Okay, shelf. How many different arrangements are possible if the books in each particular subject must all be together? Only the mathematics books must be together. So now see here, mathematics books are 5, these books are 2, and these books are uh, okay, 4 mathematics books, 5 CO books, and 2 GDC books. So first thing they are saying, all the each particular subject must be together. Okay, so here see, mathematics books can be arranged among 4 factorial ways, co books can be arranged in 5 factorial ways, and GTC books can be arranged in 2 factorial ways. Okay, so now they have said, okay, so this can be arranged also groups in 3 factorial ways, and the 3 groups in 3 factorial. So now this is what they have said, all subjects must be together. This is 1, this will become 1, this will become 1. So totally I have 3 groups itself. So 3 books types. They are saying that all are together means this will become this, this, this. I'll add all. 5, 4 I'll consider as only 1. This 5 books I'll consider as only 1. Complete 4 or 5 will become 1, and complete 2 will become 1. So how many are there? 3 are there. So I'll take 3 factorial. That's what this question is asked. All particular subjects must all be together. So how many subjects are there? So even though you have a multiple number of books, that will become only 1 book. So totally 1, 1, 1. So 3 subjects are there. So 3 factorial. Second question, all mathematics books must be together. So what will happen? Only maths books will be 1. Remaining I have 5 factorial into 2 factorial, like that. Number of possible arrangements are 4 factorial into 5 factorial into 2 factorial into, now they all should be together, that is here 3 factorial, they are multiplying. The GTC books can be arranged among the in 2 factorial ways, and the 3 groups in 3 factorial ways. First, individual book, how many ways it is being arranged? 4 factorial, 5 factorial, 2 factorial. Then all are grouped together, how they can be arranged? 3 factorial ways. So we have to multiply all these 3. So this 4 into 5 factorial into 2 factorial, 3 factorial. You will get this answer. In second question condition, all the mathematics books are one single book now. Then we have 8 books. Totally how many books are there? 4 plus 5 plus 2. 5, 6, 7. 7 plus 4 is 11. But now this will become 1. So this will be like only acting as 1. 5, 6, 7, 8. Okay, here only 8 other. Here I just said this, okay, don't get confused. This thing, 3 groups we took, right? So 1 group, 2 group, 3 groups. So that gives us 3 factorial into this factorial into this factorial into this one, like that it was. Now we are doing this. So only 8 books are there, which can be arranged in 8 factorial ways. But the mathematical books can be arranged among themselves in 4 factorials. Therefore, the required arrangement is 8 factorial into 4 factorial is equals to y. Why here 4 factorial comes? Because total number of books. What they have, only the mathematics books must be together. Okay, 4 books are there. 4 books are there, right? Mathematicals. Now this I have grouped as one. So 4 books together, I have bundled it. So now this will be acting as one book, then 5 this CO books, and then 2. So how many other? 8 are there. Now 8 factorial. So totally I have 8 factorial. But in that 8 factorial, this mathematical book can be in middle of this 5 books, can also in middle of these 2 books. So like that 4 books are there, right? So it can be these 4 books can be grouped, bundled together in 4 factorial ways. That's why we are multiplying 8 factorial into 4 factorial. This is my answer. Now this finishes with what to say permutation. Now combinations. selecting a set of R objects from a set of N objects. Okay, so let me just make combinations separately now, okay, in separate video. So I'll just do it and in another kind of video.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.